Hi donors, I'm Dr. Naginey, the physics teacher in the upper school. I just wanted to say thank you so much for your donation to the annual fund. It really means so much to all of us here at North Cross School. To say thank you in a personalized way, I wanted to do it the best way I knew how, which is with a little physics lesson. I'm going to explain all the symbols you see in front of you on your screen in terms of what they mean in physics, but I'm going to have to go really fast, so you might want to take notes. Tau is torque. It's any force that causes rotational motion, and it's defined as the cross product between the radial vector, which points from the center of motion to the point at which the force is applied, and the force itself. Hbar is the reduced Planck's constant. It's equal to Planck's constant divided by 2 pi, where Planck's constant is about 6.62 times 10 to the negative 34th joule seconds. That might seem like a real small number, but it's not zero, which is very important in quantum mechanics. Alpha is the fine structure constant. It has to do with the coupling, the strength of the coupling between the electrons and the quantized electromagnetic field. N is the principal quantum number. It tells us something about the energy levels that electrons are allowed to occupy in an atom. The K vector is related to the crystal momentum of an electron in a periodic solid. Anytime that you solve Schrodinger's equation in a periodic potential, you get this new quantum number that we call K. It's a vector that represents something related to the momentum. Gamma, well, this is the gamma factor in special relativity. It's 1 over the square root of 1 minus v squared over c squared. And the ratio of v squared over c squared tells you something about how close you're getting to relativistic effects. Theta, this one just means the angle. In physics, we usually measure angles in radians. 2 pi radians equals 360 degrees, things like that. U is usually used to represent potential energy. So for instance, gravitational potential energy in an approximately constant gravitational field near the Earth's surface would be mass times the gravitational constant times height. And this is the symbol that means factorial. So typically, what that means is you multiply a number times that number minus 1 times that number minus 2 all the way down to 1. Really, that is just a simplification of the gamma function. The gamma function of any integer is that integer minus 1 factorial. But if we generalize to the gamma function of imaginary numbers, it can be defined by this indefinite integral here. And it's a very powerful tool, especially in statistical mechanics and physics. Well, I hope you enjoyed that brief physics lesson, and just thank you again from all of us here at North Cross. Bye-bye.